Hello, my name is Maria Adrián. I'm an industrial engineer. And well, today is the third session of this cycle of seminars. And the program I'm going to talk about is CYPETHERM Loads. Okay, let me do something. If you don't mind, I'm going to stop sharing the camera because this makes my computer slower. Okay, so now that you have seen that I'm a person, I'm going to stop sharing this, and then maybe afterwards I'll say goodbye again. Okay, thank you for understanding. Okay, well, of course, feel free to ask any question you have in the chat. Right, there is in the webinar, you will see a little window where you can write anything, and I'll try to answer at the, well, maybe while I'm doing the presentation, or maybe when I finish, depending on the question. Okay. Don't worry about that. You can ask any question. Okay. Well, the program we're going to talk about is CYPETHERM Loads. Okay. This program is very complete, and the aim of the goal of the program is to calculate the thermal loads of a building. Okay. First of all, well, I think we are going to do this in 2 steps. Firstly, I'm going to show you a complete job, so you can see how this is when it's finished, the way everything is, and how you can see the reports and everything. And then we'll do an example step by step, a smaller example step by step. Okay, so this is what we are going to do. I'm going to show you first in my account of BIMserver.center. I have this project that I called the UBAT Complete Project. This project is a big project of a hotel. Okay, with IFC, I created the geometry with IFC Builder. Here we can see the 3D view of this building. Okay, so the next step was to export it to the project. So that's why we continued with CYPETHERM Loads. And that's why we can see here the 3D of the building. Okay, what are the main features of this program? One thing that is, I think is very interesting, that if you come here to the Thermal Loads tab, here in the first button, you can see a little overview of the features of the program. Okay, so anytime you can come here and see which method we use. That is the radiant time series method, and the main features of the program, which calculations it does, the database that we use for the weather data, and also the solar radiation database based on the Ashrae that we use. We can get the thermal cooling load results for the 24 hours of design day, okay, the worst case, and real-time result graphs. So let's see, I'll show you this better in the file. Okay, so for example, what kind of features I think are quite interesting? If we are here, for example, in the building, we can see the tree of the different elements of the file. Okay, in libraries, you can see spaces, facades, partition walls. Every time we select something, it is going to be in color in the 3D. Okay, so we can see what we are talking about. Okay, one thing that I find quite interesting, when in the definition of the spaces, here, let's for example, the room hotel is a type of space I have defined. Here, of course, you can create everything by hand, but you have very good help here. Every time you see this blue arrow, This means there is help, and the help is from a very good source, the ANSI Ashrae standard. So this helps us define the internal requirements, for example, for the minimum ventilation rates in whatever type of zone we are. For example, a correctional facility, educational facilities, in general. Well, this is from this source. Okay, this is, for example, the program help us with the ventilation ratios. Also, with the occupant density, again, we find this blue arrow, so we can get access to this source. The same happens with the sensible heat gain, radiant fraction, and latent heat gain. We press here. Always when we have every time the program tells us which is the source where this comes from. With the internal requirement, happens the same. We have a series of options, predefined options. And with lighting power densities, so it's quite useful or handy to have this instead of working from scratch. Another feature that I find quite interesting is the fact that in the different spaces, we are able to define schedules. So instead of being something always with the same value, we can choose, this for example could be constant, but we could choose a profile. And here we could create, for example, say that from maybe at night, there's a very small amount of use of whatever it is. And then, sorry, we can, okay, for example, like that, or very, very small values. And then at other hours, we choose 100%, or it could be lower, depending on the hours. Okay, the profile we prefer. There are, I have some predefined values, for example, like this one. Okay, that nothing in at night time, and in the office hours, I have this 100%. This could be an example. Okay, we can create as much as we want and export to libraries and import again in other jobs. Okay, that's the fact that we have the help of the Ashrae database. Another interesting thing is that in the definition of the constructive elements, we have a number of predefined options, because we could create something from scratch, layer by layer, totally free to do this, but it's really interesting the representative materials from the Ashrae Handbook Fundamentals that we have included in our program. This is only for materials one by one, particular materials, but we also have the option of creating an entire wall type. For example, we could create these brick walls unit. If you are familiar with the Ashrae handbook, you will know this. For example, the 13th option, we can do like this, and in one, as this first, we have created this type of wall. Okay, the same happens with all the constructive elements, all right? The same I explained it with facades is with partition walls, okay, and underground walls, slab on ground floors, depending on the we do have or not. In this case, there's a parking floor or garage floor, the floor slabs. As you see, the program tells us where you have this in the 3D. So we navigate here. Then the roofs. Okay, and well, this is about the type of sources we have. Another thing that is quite useful in this program is that you see here the thermal bridges. The program generates, is able to read from IFC Builder. As IFC Builder creates the analytical model, it's prepared to read automatically all the different bridges one by one. In this example, we have 338 linear thermal bridges. Okay, it is possible to give values one by one, but there's a very interesting tool that is this in BIMserver.center edges, which allows us to do an automatic process of these thermal bridges. We could use, for example, this code and in seconds, okay, have the values for all the linear thermal bridges of the file. Okay, this is about the building tab, but there are more features in the thermal loads tab. In thermal loads, something that helps quite a lot with the introduction of the first data is this. In project, because in building spaces, we define the conditions we want inside the space. Okay, this could be the temperature we want and the relative humidity we want in cooling, when we have cooling needs and when we have heating needs. This is what we want inside, but we have to define also what we want outside. Or no, not what we have outside, sorry. What are the external conditions? This is something that depends on the location of the building. How can we do this? How can we define the external conditions? Here in project location data, we could one by one define all these values. Okay, give the type of temperature, relative humidity, ground temperature, and so on. This is possible, of course, but this is here we have this really interesting tool that is the import of the Ashrae weather data viewer. In this, you will find, for example, for any region really, but if we want to calculate in your country, for example, we could choose the second option, Asia, Bangladesh, and then select from the state which station name we want to, which station we want to use. In this case, I choose Dhaka, and well, if I accept, these are the values that I'm going to have. If I can change something if I know that in my place is not really in this exact position, but maybe in a lower, with lower elevation or higher or whatever, I could choose a cell and change the value. Okay, this is understood. Okay, another interesting thing is that once we have done this, we can copy or save it in our computer. So next time I just have to click here and use it. All right. Okay. Well, now that I'm showing you this, one thing that is important to know is that it is possible to change the units. Okay. In my case, I feel, well, I'm used to watts and 0 dates, etc. But I suppose some of you prefer other units. Okay, everything I show you was in these units, in international units. Okay, of course it's possible to change the system. How do we do this? Here, from configuration, units, there are predefined measure units for primary measure units, general measure units, and thermal measure units. That's why I was seeing everything, for example, the heat transfer coefficient in watts per square meter Kelvin. If we want to change this, we can do it manually, one by one, clicking in the cell and then selecting another value in the list, or we could click here. Remember this, the blue arrow is our friend. We press here, and instead of the international system, we could choose the IP system, and automatically every unit will change. So now, if I edit any element, for example, the facades, I can see them in these units. Maybe it's a good idea. Maybe you feel more comfortable with some units, and then you can change it for the reports. Okay, so that's up to you. Okay, and well, that's more or less, well, yes, the main feature, I think I explained the main features. Well, maybe another one is the calculation options that is here, that allows us to choose which analysis method we want to use. This is European, or this other is international. So in your case, I suppose this is the best option. And we can choose if we want to calculate the lifetime load for the heating loads calculation. We can consider a safety factor. This is for all the building. Or we could use a safety factor depending on the orientation of the different partitions. I mean, the walls, for example, every facade, if they are with the north orientation, they could have a 20% of safety factor, 0 for the south, 10% for the west, and east, and 10% for the west. This is optional. Okay, you could change it. And then about the cooling loads calculation, you can choose if you want to have an annual value or monthly value. And in the case of the monthly value, we can choose if we want to calculate all the months or only some months. Maybe imagine it's a school, for example, and the school is closed in July and August. So there's no need to calculate in those months. So I do like this, and then I would, these months will not be considered in the calculation. I leave all year in this case. And also, well, for the cooling loads calculation, we have an optional latent cooling factor and a sensible cooling factor. All right, let's save it. In case you want to go back to the default values, there's always the option of pressing default settings, and we go back. In this case, I'll change like this. Okay. And the other thing is the hypothesis that this means how many if the conditioned spaces. 1 second. This means if the conditioned spaces are going to be calculated at the same time or not. In this case, for example, that we have a BRF system for the hotel, everything is in the same group of spaces. When we do the little example, I'll explain it with more detail, okay? But just for now, in this case, we have one group selection. What do we get when we calculate? I have to say that this program is quite fast. Things that we can get for the complete group of spaces or so, we can get for the simultaneous peak cooling load. Imagine this. Well, in this case, we're talking about the conditioned spaces. There are so many spaces. Okay, as you see here, but you see that we can get quite a lot of information, the loads for each of the spaces and the total cooling load. Also, we could see the hourly cooling load progression, annual peak cooling load progression, the peak heating load, and well, the calculations overview. Here, you can see the complete report. that, of course, can be exported in different formats, for example, in PDF. I'm in another folder now. This is the complete project, okay. In this case, there are 275 pages. You can imagine, because there are so many spaces in this project. You can, of course, not also generate a file, complete report, but also print it. If you want, you can print it with your printer. Okay. Here we have the complete the complete report of the hotel. All the information which I'm sure you like to analyze if it's what you are studying. I suppose you will find this quite interesting. Okay, with all the graphs, everything I have shown you for the show is here, very, very detailed. Also, sorry, you can see this for the complete zone, but also for each space. Okay, so we can generate the graphs for space by space. For example, GF Office is one of the spaces. You can see here, this one. You could see this, the non-solar, solar, the cooling loads. Even, for example, imagine it's in January, it's different. You can see if it's a ventilation part, and if you want to stop seeing that part, for example, you unselect it, and this was the green. Okay, you can zoom in a bit. This is the, for example, the ventilation part, the part of the linear thermal bridges. So quite interesting to know how much is the repercussion of this, the internal heat gain, fenestration, okay, the windows, opaque envelope, and the total amount, which is the blue. Maybe we want to see only the blue part, so you can do like this, for example, okay, and this can be captured, printed in different ways, okay? Well, everything, and a big cooling progression, you can see, analyze everything, and the complete cooling loads report for this space. Well, this is, as I said, for the zone, this is for the space, and even for the different parts of the space, the ventilation, we have the graphs for the ventilation infiltration of this space, the internal heat gain, divided in occupancy, lighting, internal equipment, and miscellaneous loads, and the walls. You can see not only the equation that we are using, but also the different, well, this is the layers of these are the layers of the facade, but also the graph, okay, temperature and solar irradiation, the cooling load, and the, as I said, the equation. But this is the default value, okay? This maybe could be the most interesting part of this. Okay, so, well, more or less, I think I said everything about what you get in a complete project. Maybe only to say that you can get from here, you can get reports from here also, and that there are complementary reports about the description of materials, of the construction elements. You get a list of all the constructive elements that you have used in the file with the properties. And well, in case of having calculated the reduction factor of the spaces, you can get the complete explanation. Okay, so that's about the finished file. Now I would like to show you an example step by step, so you can understand and see the flow. So 1 second, please, and I'll do this. I'm going to close CYPETHERM Loads. This and here I'll show you something. My computer is doing funny things. Okay, now I'll explain you step by step. Here, in my desktop, I created a folder with the name restaurant, what, because it's a little example I want to do. Okay, so there's a folder with a file which has this extension, CBIM. Okay, this is the extension of IFC Builder. So this is what I'm going to open. Here in IFC Builder, in recent files, I have this file. Okay, this file was introduced in this program, which I encourage you to try because it's really easy and fast. In this program, we can start a project from create the analytical model from scratch, from an empty job, and it can be done without any help at all. You can start drawing like that and create the spread, and then create a space. Just clicking inside, we have the space. The program is ready to calculate the area, volume, etc. of this space. So it's really, well, I encourage you to use it, okay? Well, with this can be like that. I didn't use any help in order to do this. I can use this if I want. So the program tells me the length of every element. So it's better, maybe. Easier. Sorry. Okay, we do like this, 5 meters, and then continue like that. Okay, so that could be one option. And maybe remember this, okay? The allows to say the dimension of everything I draw. And also, I want to delete it now, so I don't confuse you. Add space. Let's delete this. In this case, for example, this wasn't introduced like that, but with the help of a drawing. You can use a DXFWG, this, okay, that was introduced with this button. I know that Vicente already explained you this in the first session, but it's only in case somebody has forgotten the way this works, okay? A little explanation. With this button, you insert the WG, and then with this button, you say which drawing you want to see when you are in this floor. So that's what we use to draw this. If we select this layer, we can see that this is the template used in order to draw the the different constructive elements. Okay, so that's the file. In this case, it has only two groups, which in this case are the plants. Okay, we create it here. This is a 2 floors building. And what is very important to know is that here we only say the height of every level, and here of course the orientation, very important for the loads. With this option, you define the different the orientation of the building, so the program knows that this is north, south, etc. Okay. Then in the architecture part, we define the different construction elements, and in this case, this program is very basic in the sense that we just have to say, for example, if it's an external wall, we have to say if it's like this external or party wall and the thickness that this has. We don't say the layers. This will be done afterwards. In this program, only the names. The name of the wall, the name of the partitions, and okay, the name of the, if we are talking about the openings, the name of the different openings with the dimensions, but not properties, not thermal properties. Another thing that is done here is the order is the logical order. First, we create the construction, we insert and create the construction elements, and then the spaces. Here we have the different spaces, for example, the dining room, in which only we have to say if it's external or not. We have to create as many type of spaces as different spaces with different properties we will have. For example, the dining room is a type of space, the kitchen is another, but the toilet is the same for men and for women. It will have the same properties. Each time we need a toilet, we create a new reference. That's why we have toilet woman and toilet men, but the definition of the space is the same. Okay, that's quite important to understand. The thing is here the type of spaces, and another thing is the different elements we have with those properties. Okay, that's it. Construction elements, spaces, and then groups of spaces. This part is optional, but can be very handy if we are going to go to CYPETHERM Loads. So that's why I'm going to explain you this. This will be faster. I'll go faster in CYPETHERM Loads if I have done this right. How do I do this? I say new edit, group of spaces, and I can create, for example, a conditional spaces, for example, and I can choose a color. For example, yes, yellow is fine, accept, and then what I'm going to do is assign the dining room and the kitchen to the conditional spaces. That's why I see these spaces now with this color. And then I can create another for unconditional spaces. These can be, for example, brown. Sorry, I want the branch from here. Unconditional. Otherwise, it could be a subgroup, and it's more complicated to understand. The conditional spaces like that. Now it's better. Okay, the hierarchy I want. So now with assign, I say that this and this goes to the other group of spaces. If I do this, now let's save. Well, that's I cover everything at the construction spaces, group of spaces, and now nearby volumes in case we want to, we have buildings nearby and we want the shadows to be considered. In this example, I suppose I don't have this case, but okay? Okay, so what I do next, I'm going to export. I press this. I'm in restaurant evaluate project, and let's give a name. I'll give it restaurant initiator. I'll give it this name because you'll see later that is handy. Okay, let's export. We can check here to see that the file is loading. With this blue arrow, it says that it's now doing something. Let's wait a little bit. Of course, I suppose you have already installed the synchronizer. It's very important to install the programs and also the synchronizer. Okay, this is finished. So if I come here to my account and the project, in content, sorry, this is the other project, the complete project. I have to go to the other, to the restaurant. Here it is. Okay, a minute ago. Okay, here I can see when I did this. This is the file. And here in content, here it is. This is the name I gave it, the restaurant initiator, because it's the initiator of the project. And here it is, the GATL, the architectural model. Second. The IFC. This is really what I'm more interested in, the IFC, which is what is going to be for me the initiator, the open format I'm going to use. Of course, this can be shared. And also the program always, if we want, we create a DWG. Okay, so here it is. Okay, here is the GTF. Sorry, so it's a 3D, okay? My computer is a little bit slow this morning. Okay, but we will see it, we'll see it in a small, okay, this small view. It could be the same thing, but bigger, okay? It's just that, nothing else. Okay, let's see now what is the next step. We have created the IFC from IFC Builder, and we want to continue with CYPETHERM Loads. Okay, what will we do now? We open CYPETHERM Loads, and what we want to do is to connect with the project. So what we do is second, new, okay. Okay, here we create a new, sorry, something with the webinar. GoToWebinar, for some reason, it needs a lot of RAM, a lot of memory. It consumes a lot of memory of my computer. I'm sorry. It usually goes really faster, okay? Sorry for this. Well, let's choose the project. Give me a moment. The moment it wants to respond. Okay. To I'll open it. Okay, new file, and I'm going to choose where I want to keep it. In this case, it's going to be here in the restaurant you got folder, okay? So that's the new file. CYPETHERM Loads, and what is very, very important is that I want to select the same project I created with BIMserver, okay? The restaurant you got. The moment I do this, you see, I'm reading. That's why I gave it the name Restaurant Initiator, because this is what I want to use as initiation. And this is quite important. The program asks me if I want to import the edges, the hemisphere we are, if it's northern or southern, and the types. I accept. Import finish. Here, what I get, I wanted to show you this because I wanted to show you how this looks when we are starting from scratch. You see all these exclamation marks? This means that something is not defined. This is something I expected because if you see, for example, spaces, what did we do? Let's see, sorry, this is interfering with what I want to show you. Let's put it here or like this. Okay. Here, I didn't tell the program how is the dining room. I only said that is a space, nothing else. I have to give it properties. If I press here, I can very easily define the properties. For example, that is occupied. I want to calculate heat and cool, the heating and cooling with these options. And for example, for ventilation, I could choose that is a dining room. This could be perfect. Restaurant, dining. I can say if it has heat recovery or not, which percentage. Define infiltrations, of course. Give a schedule, as I said before. Let's keep it simple this time, okay? I don't want to be too much time. I know you are busy, so let's keep it very simple. 100% all the time, not a schedule. And with the internal heat gain, people, I could choose food and beverage for restaurant. Here, for example, I have the sedentary work for a restaurant. And let's choose this as adjust male and female heat gain. And also, I could choose the internal equipment. If you were at this, if it's imagine is this, okay, of course you can choose your own option. And for lighting, I have this very good help of the Ashrae. I'm not going to explain this before. I explained it earlier, so it's already said. And I can say that I have some miscellaneous loads. Of this, as I have finished this, the dining room is finished now. The same with toilet. The toilet, for example, I suppose that is not habitable, so I will not calculate loads for the toilet. And for example, for the kitchen, if it were the real thing, I would go one by one, defining the options. But as I'm just explaining the program, I'll show you something that is easier. So, okay, you can use this assign tool and say that the same options that the dining room has is going to be for the kitchen. If I do this, automatically this has changed. Okay? All right, now the facades. The facade doesn't have any layers, it's empty. Very easily, I can come here and say that what I have is the 13th option of the brick walls of the Ashrae handbook. I accept this, and here I have this. The exclamation part is not visible anymore. This means it's okay. For the partition wall, I can choose, for example, that I have this brick. Then the other one was slab on ground discrete, for example. I could have any material really that I I need. I could define it manually. For example, another thing I didn't show you, these the materials of one. These I could choose. I have this concrete of a certain thickness. As I don't have floor slabs in this file, this is empty and it's okay. Then for the roof, I would have to choose. I could say that I have a concrete roof, for example, the 14 of the Ashrae. Then the doors, for example, imagine I'm going to do this at the same time. For example, that I have a 2 square meter Kelvin for the 2 doors. If I do this, at the same time, I sort it. They have different dimensions, but the same thermal properties. And the glaze openings, I'll do the same, okay, because of the time. If it were a real job, of course, I would do this slower, okay, and pay more attention to the values. This is, I just want you to understand the way of working. And then the linear thermal bridges, as with the other example, we already did this. We only have to choose the code, and automatically the program has calculated. In this case, there are only 11. Okay, this is more smaller, and maybe it can be done manually if you want. But okay, that's the part of the libraries. And then about the project, as you see, I don't know if you saw that in the other project in the hotel, we had one option for each space. In this case, you see, we have conditioned spaces, and here is the kitchen and the dining room, and unconditioned spaces, and here it is the toilet woman and the toilet man. Why is this happening? Because of the group of spaces I created in IFC Builder. Okay, what does this will make it easier when I create a hypothesis? Okay, this is the building part. If I go to thermal loads tab, here I just have to select the right place for the external conditions and what kind of calculations I want to do. Let's keep it, let's do monthly also for the cooling calculation. I accept this, and I have to create a hypothesis. This is quite important. I'm going to show you 2 types of hypotheses. For example, one hypothesis could be that I want one zone that is going to be the conditioned spaces and another zone for the unconditioned spaces. This is one option, okay? Another hypothesis, I can come here and say another hypothesis in which the first zone is going to be only the kitchen, the zone 2 is going to be the dining room, and then the zone 3, the 2 toilets. What is the difference between the first hypothesis and the second one? The difference is that in one case, in this case, the program is going to calculate the losses between in the internal partitions between the kitchen and the dining room. In this case, there will it's treated as the same space with no losses in the internal partitions. It could be in vertical or horizontal. It could be a floor slab. Okay. How do we usually use this? Depending on the installation we are going to have. Maybe if it's, for example, a duct machine and the ducts are shared in the kitchen and in the dining room, for me it's more reasonable to choose this kind of hypothesis. At the same time, they will be conditioned at the same time. So we don't consider the partitions between these spaces. Imagine another case. Imagine there are different installations with no connection at all, or maybe, yes, one is using a different timetable. So in this case, it's better to separate in different zones. Okay, so depending on the installation, it can be one hypothesis could be better than other. Now we can update the results, and here we can see now it's more approachable than the other example I showed you. You will see here we can see the complete report. Remember, we had 700 pages. Now we have only 4 pages, okay? Because it's a quite smaller project, but very interesting to see how the different spaces behave month by month. And of course, you can get here, if you see, for example, this zone, you can get the complete report, and also the kitchen and the dining room, now only 2 spaces, the condition of the spaces. We can see the simultaneous peak cooling load, early, month by. This is for cooling, as I selected a monthly, so I can see month by month how the 2 spaces behave, and heating load, and the overview calculations. It could be, this is for the entire zone, and also you can see it for each space. For the kitchen, okay. That, and again, month by month, if we're talking about cooling, if it's heating, only 1 value. And again, the same for the dining room. And also, we could, for example, for the dining room, you can have access to different results for the space. Talking about the ventilation, internal heat gain, the walls for each facade. This is the orientation in brackets, and also the different partitions. In this case, as is the case, see like this. This partition is the partition in the same zone. So is 0. The value is 0. I'm considering that there is no loss of energy. In this case, if we're talking about the non-conditioned, because these are the toilets, there is cooling down. Okay, so well, this is more or less everything. These things, these elements can be, these graphs can be, imagine you are interested in this graph, for example. You could press here and get a DWG or DXF or even or an image GPG or a BMP. You can save it wherever you want in your computer and use it in your reports or in anything you are doing. Okay, so well, now that this is finished, I can export it. See here, I can export the hypothesis 1, the second one, or the one or the other, sorry, one of those, because the thing of this, what is really interesting about this is not only that we can read it, we can have it in the platform, which is good to have it in the platform. For example, here, what is, this is now uploading. We have to wait a little bit. What is really interesting from my point of view is that we can see this in other programs. Okay, if you see here, okay, here the thermal loads. This is good to have this the different. I think the problem is with the webinar is too much memory. Well, anything. Sorry. Here we have the you can share, because the one interesting thing about this is that this project is only myself, but I can have a work team and invite users. I could invite users to my project, so I can share with them my results. Okay, so they can see the reports, and not only that. The thing is that they can see all the content that is in the platform, but they can continue with other program and read the results. And what I'm going to explain tomorrow, the program I'm going to explain tomorrow is OpenBIN. And I hope you come back tomorrow and you will see how OpenBIN is going to read the loads this program, OpenBIN, is going to be able to read the loads calculations from this file. So that's about it. Okay, the thing is that we not only read the results or export the results, but they are exported for other programs. So there is a consistency between the different programs, and maybe imagine we can make a change in the loads because, for example, we want to have a different ledger for a wall, for example. If we export it again with new results, then the other programs will read these other results, etc. Okay, so but this will be tomorrow. Today's program was CYPETHERM Loads, and I think more or less I have explained everything. Of course, this meeting has been recorded, so maybe if you have any doubt, you can see it again and ask any question. One thing that I don't want to forget to explain is that here in the platform in BIMserver.center, there is here, okay, if you choose in the store, some reason will come here in the store. If I write, for example, loads here, you will see of course, the program in order to download it, and also the contact information. Here is our email. You can write to this email and ask any question you have about this seminar, for example, about today's seminar, or any other question you may have. And also check here in available resources. There are some interesting things that have been done in the past. For example, this tutorial of CYPETHERM Loads in this case. Okay, so maybe anytime you can come here and see this seminar. Okay, this is a 1 hour seminar about CYPETHERM Loads, so anytime you can come to here. Okay, so if you have any questions, please ask. This is a good moment. You can write in the chat any question you have. And also, if maybe the questions will come later. If you have questions later, don't hesitate to write me to support@cype.com. As I said, my name is Maria Adrian. Maybe you can write it in the chat. Don't hesitate to contact. Okay, I see that nobody is writing in the chat. I don't know. I hope you like it. You will enjoy the seminar. You find it interesting. I invite you to come back tomorrow at the same time. No, it's a little bit earlier, half an hour earlier tomorrow. I suppose all of you have already the invitations to the webinar. Okay, so next day is going to be a continuation of today's, because I'll explain OpenBIN. a vendor's program. So it's, well, I think it's interesting to continue. Well, if nobody says anything, please confirm that you are listening to me. I see that there's people, so I suppose you are there, but okay. Okay, so I think there are no questions. Thank you very much for coming to this seminar. I'm going to stop recording. And again, I hope I'll see you tomorrow. Thank you very much for your time.